So we're talking about quantitative data distributions. This is an example of one. Remember, a distribution is just all the values of a variable. In this case, our variable is house price, listing price. These are all the values of it on the x-axis here, along with the associated frequencies. As you can see, the y-axis is frequency here. So this is a distribution. Yesterday we talked about the different categories we want to discuss. I've summarized them here for you. The required categories are center, where is the distribution centered? How much variability exists? The spread. Comments about the shape. Modality, as I call it. Unimodal, bimodal, multimodal. It has to do with the number of peaks. Whether it's symmetric, or if it's not symmetric, is it skewed to the left or skewed to the right? You can also make other comments about the shape that we didn't talk about. For example, how peaked the distribution is. There's actually a name for this. It's called kurtosis. It sounds like a disease. So if you study Greek, you'll understand these words better. Leptokurtic means that it's very tall. I think lepto is like skinny in Greek. And platykurtic means that it's flat, like a plateau. Also, there's something called a uniform distribution or an even distribution. That just means it has a flat top. So you might see that word. And then lastly, you definitely want to mention if there are any outliers, because those can have a drastic effect on the statistics that you calculate. Okay? And we expect that you will have these committed to memory, so that we'll just ask you to describe without any framework, and you touch upon all these things. Any questions on any of those things? Yes?
Can you explain IQR again?
I'm not going to explain IQR right now, because we will learn that later. You can Google it. Any other questions on any of these? Okay. So this worksheet here will let us practice describing using each one of these categories. I got this data from Realtor.com back in 2010. I don't expect it to be much different now. These values are in thousands of dollars, so this means $600,000. This means $1.2 million. And our first question is, if a friend of yours asked, how much does a house in Tenafly cost, what would you say? Now, obviously, there's not one answer to this question. That was deliberate on my part. So we'll ask a random person. Glenn?
I said somewhere between 200,000 to 4.2 million.
Okay, so he used the entire range, the entire spread. Somewhere between 200,000, which is this first category here, and 4.2 million. Okay? I'll go to a volunteer.
I'd say around 1.2 million.
Around 1.2 million. Okay? So I presume that you thought that was the center?
Yeah.
Okay. Dan?
I'd say it depends on how nice the house is.
Sure. It's greatly dependent. Any others? Yeah.
I said around 800,000.
Around 800,000? And why did you choose that?
Because there is a really high frequency on 600,000, but there are a lot involved in the more expensive.
Sure.
And so I think if you did the unit added, it would be somewhere in between 600 and 1200 and 800.
Okay, so you estimated the mean, and she estimated it to be around $800,000. And she made a comment about the mode. $600,000 is the mode here. It's the most frequent price. So I think it's reasonable to say $600,000 is typical in Tenafly. But keep in mind that there's a large percentage of homes that are more expensive than that. Okay. Good. I think all those are valid. Next, the list price of homes in Tenafly ranges from approximately blank to blank. Well, Glenn answered this question. 200,000 to 4.2 million. That's quite a spread. So this is one of the categories we want to discuss always, spread. how much variability exists in the data. Mean or median is never enough. Okay, Hiji, what was your guess as to the median? 2 million, which would be here. Okay. So the thing about median is that it splits the distribution in two, meaning that you will have half of the data below it and half of the data above it. So I think that estimate is too high. Would you like to revise it? Maybe 800,000? Okay. I think that's more reasonable. Any other guesses? 600,000? Okay. I think that might be a little too low. Remember, you want half the houses below and half the houses above.
Like 900,000?
900,000? So this is 8. So maybe like here?
Yeah.
I think that's more reasonable. Okay? So just write down your guess. It doesn't matter. It's part of the training to match up to improve your guessing ability. Okay. Next. Glenn, what was your guess for the mean?
I said 120,000.
Do you mean 1.2 million?
Oh, yeah. Sorry, 1.2 million.
Okay. And what was your thought process there?
Because the mean's like the average, so
Mhm.
I felt like the houses all the way on the right are way more expensive
Yeah.
than the ones on the left, but there are more houses on the left, so I
Mhm.
felt like 1.2 million is kind of like in the middle.
Got it. The mean does not necessarily split the distribution in two,
Yeah.
like the median does. As Glenn was saying, we have a lot of houses here that are extremely expensive, and we need to balance them out. And yes, it is true that the bulk of your houses are on the low end, and you need to account for that, but you also need to balance these homes on the extreme high end. Okay? So I think 1.2 million is a reasonable figure. But you write down what your guess is for the mean. Note, however, that your guess for the mean is probably higher than your guess for the median. Did you notice that?
Yeah.
Okay. So I'll just write down some numbers here.
Is there a way to tell from just adding in there to tell the difference between the median and the median and the mean?
Yeah. Look at the skew. This one has extreme skew to the right, or extreme positive skew. The mean is going to follow that skew. The median, generally not affected by it. Okay? Good. So this is the other category we want to discuss, center. Where is the distribution centered? And sometimes it's more appropriate to use the median, and sometimes it's more appropriate to use the mean. We'll discuss that later. Okay, now on to the shape, the other main category we want to discuss. We'll start with symmetry or skew. So Ethan, is this a symmetric distribution?
No.
Definitely not.
I said it was bimodal and it was skewed to the
Okay, we'll hold off on the modality later, till later. Definitely skewed to the right. The convention is that it's skewed in the direction of the tail. Of the longer tail, I guess I should say. And so our tail is on the right-hand side, so this is called skew to the right. Which means that the bulk of your data is on the left. And what's implied here is that it is asymmetric, since it's skewed. Any questions on skew or symmetry? Okay, now, clusters or modes. Laura, what did you say?
I said unimodal
Okay. And what was your reasoning?
because there's one big dip, and then the second dip is not as relevant for them.
Okay. Yeah, I think that's reasonable. Any others regarding modes? Yes.
Could you do the kurtosis in this section?
Yes,
There was some class.
we could, but I'm not going to.
I said bimodal, but I was also wondering about that secondary function there,
Mm-hmm.
whether that would make it more or not.
Yeah.
What's the significance of that?
There's no objective measure. I would consider this to be potentially multimodal. I see this as the definite primary mode, centered at $600,000. I think we can all agree there. However, it looks like we have another mode at 1.4 million. This could be a distinct classification. I would need to do investigation. It could be chance, like it could be sampling variability that we're seeing this thing. But as a statistician or somebody working with statistics, I'm definitely going to investigate this to see if there's a commonality here. Also, you could say that this is a tertiary mode over here. Tertiary referring to third. Okay? What's most important, though, is you can support your answer. And if you're going to say that this is a unimodal distribution, then I would say you need to make some statement about this. Okay?
What would that statement be?
That you don't believe this is a second mode. Okay. So I will say, apparently, multimodal we have a primary mode at $600,000, a secondary mode at $1.4 million, and possibly a tertiary mode at 2.8. 4, 6, yeah. Any questions on modes or clusters? Next, Maria, would you say there are any outliers in this distribution?
No, there's not really any that are like way off. Yeah.
I agree. There's no clear outlier or outliers here. One could make the argument that these homes that are 2.6 million and above are outlying or mildly outlying. As you can see, you have a gap here, but the gap is not huge. It's only $200,000. And when your home is worth $2 million or more, $200,000 is not huge. Okay? Again, no objective measure that everyone can agree upon about what an outlier is. What's more important is that you understand the concept of outliers and what their effects are. Okay? So these homes that we could possibly consider outlying are going to do things like make the mean higher, have a drastic effect on things like standard deviation. That's what's more important. Okay. They're the unusual ones. Unusually expensive even for Tenafly. Okay. Any questions or comments on outliers? So definitely make sure to comment on that. Lucy, what do you think the bin size is here? And I'm referring to the category size. $15? $50? Okay. Where are you getting 50? All the homes are different? Okay, maybe I'm not making it clear. So, okay. So when I say bin size, I'm referring to the size of each category. Each category being represented by a bar. Here. Now we're in agreement.
So it's not the number of categories?
It is not the number of categories. It is the size of each bin. Okay? Each bucket. Think of each of these bars as a bucket that's being filled. So this is the 200,000 bin. This is the 400,000 bin, 600,000 bin, etc. This bin that's labeled 600,000 actually contains homes that are between 500,000 and 700,000. 600,000 is the midpoint between those two. So our bin size is $200,000. But what do you think? Do you think that's appropriate? Or do you think it's too small or too big? Yes?
I think in this case, because we're dealing with houses that are a couple of $100,000, it's appropriate because if you were to do each one by $100,000, it would be like become disorganized because you have too many.
Okay.
$200,000, yeah, it's like a lot of money, but it's not like going from 0 to 1,000. Like when you're buying a house, you're expecting to spend a couple $100,000.
Mm-hmm.
So like I feel like it's fine.
Okay. Did you have something to say? Okay. When I think about bin size choice, what I think about is what would make two values distinct. Like think about SAT scores. If somebody has an SAT math score of 740 and the other one has an SAT math score of 750, can you distinguish those two students? Probably not, right? So we probably want a bin size that's bigger than 10. Like think about natural groupings. In this case here, we want to ask ourselves, can we distinguish between two homes that are $200,000 apart? Probably. So we might want to choose something that's a little smaller than that. However, if you choose something that's smaller, just keep in mind that you'll have more bars, and it might just be a little more difficult to analyze and to make generalizations from. Okay? You could also easily go too big. For example, if you made the bin size 500,000, you're grouping all the homes between $0 and $500,000 together. And I don't think that would be wise. Okay? Because there's a lot of distinction that can be made within homes in that category. So in summary, I think that this is a pretty good choice. We might go a little bit smaller. I'll say given that homes are several $100,000 normally, this bin size seems appropriate. And I'll say there isn't much difference between homes that are $200,000 apart. Like I said, we could go a little lower. Okay, any questions on that? At my old job as an engineer, what I would do when I was analyzing data like this is I would make the bin size as small as possible so I could pick out features, for example, modes popping up distinct from other modes. But I wouldn't go too small because, like Laura was alluding to, it becomes difficult to analyze. Because then you just get a bunch of like gaps in between bars, and a lot of bars only have one thing in them. And it's hard to make generalizations. Okay. Next, Daniel, any unusual features?
There is just a gap in the 2,400,000 mark.
Yes.
It's not too unusual because it's only it picks up shortly after, but maybe it's worth kind of noting.
Sure. So one of the things that you can talk about with distributions are any gaps. We have one at 2.4 million. Like Daniel said, I don't think it's that unusual. If there was a gap of like $1 million, that would be more unusual. Yes?
Yeah, I don't think it's that unusual also because like it depends on who they surveyed. So it just could be like the fact that they only like surveyed like 100 people and they didn't get that one. There could be like a few other people that have houses that big.
Sure. If we were to look at all Tenafly homes, remember these are just the homes that were listed on Realtor.com. So these are homes that are for sale as of this date. If we looked at all the homes in Tenafly, we could certainly get one that's 2.4 million plus or minus 100,000. Okay. Unusual is really up to you. It's really anything that is against your expectation. You could consider multimodality to be unusual, depending on what you're expecting. Okay? Or outliers, or skew. It's a subjective category. Okay? Any questions on commenting on quantitative data distribution, covering center, spread, shape? Okay. Yeah, and Maria, back to your comment about kurtosis. This is a pretty leptokurtic distribution.
Yeah.
Yeah, it's pretty peaked. You have a lot of homes that are concentrated around this primary mode here. Backside. Now let's hypothesize. For this, I'll go to a volunteer. We have heavy skew to the right here. Ethan.
I feel interesting because there are not that many people that can afford a house that is like above like $1.2 million. So that's why like the average like annual income you have to look at it, but like I assume that it would be much closer to $600,000 because that's like the average of the house.
Yes. So when a distribution is skewed to the right, it means that we have just a few values that are extreme on the high end, and that the bulk of our distribution is on the low end. And I agree with what Ethan said as a possibility for this. Since there's a limited amount of money out there, and there's not an equal wealth distribution, there are few people who could afford homes that are, in multi-million-dollar range, let's call it. There's going to be a lot more people who can afford homes on the low end. Another reason for the skew to the right is we can't have a negative house price. So this distribution is not free to have a tail on the left-hand side. Okay? Next hypothesis. Someone else. Why do you think there are multiple modes, or possibly multiple modes?
Because people in Tenafly have different incomes. Like some people are making 1.2 million, some people are making 600,000 million. So the people that are making 600,000 are buying homes that are worth around their income.
Okay, I agree with you. There is a variety of home prices in Tenafly.
Yeah.
What I'm asking is something more specific.
Okay.
Why do you think we have apparent clustering going on?
Okay. Because the average income is closer to like $600,000, $900,000, rather than there are still people who are making $3 million, but there are more people making $600,000. So they're buying homes that are that price.
Okay, I will say what I said again. Why do you think we have distinction? Because you just repeated what you said initially, that there's a variety of incomes.
Yeah, because more people are making that amount. Alright, never mind.
You got to tell me why there are classes, Teo.
I would think that each mode would represent a different part of town.
Could be.
For example,
Mm-hmm.
Closer to town, on the hill.
Yes.
Alpine, maybe.
Yes. Well, this is not Alpine, but yeah.
But that's what I'm trying to say. Different neighborhoods in Tenafly that might just, in general, because of just how it worked out, have houses that are more expensive or larger.
Yes, I think that's a valid hypothesis. Mara?
I think it could represent like 3 different income classes.
Okay.
Because there's like 3 humps.
Okay. Why do you think there would be that classification?
I mean, I think that's like anywhere there's like 3 classes. I guess you could say like lower income, middle, and then high. So I think that's what it is.
Okay. Can you think of a reason why there's just not like a smooth continuum?
Because not everyone's making millions of dollars.
Well, true, but it's like what I was telling Glenn before. There's a difference between just having a variety of incomes and having distinct classes where we can pick out, for example here, homes that are around 1.4 million versus homes that are around 600,000. Does that make sense? Okay. Dan?
I think it's because there's the type of house you buy can be categorized.
Okay.
For example, you can have a 2-bedroom house that's worth, say, $600,000, and a 3-bedroom house that's worth $800,000.
Okay.
Like if someone makes someone in the middle, you can't have a house with 2.27 bedrooms.
Okay.
So you have to sort of split it up into different categories.
Okay, so there might be something about the house, for example, the number of bedrooms, that's creating this apparent classification. Sure. Okay, yeah.
I think it also has to do with the family,
Family?
because someone with 6 kids is going to have to buy a much bigger house than someone with 2 kids. So
Okay.
you can say that the clusters are divided based on like your family needs.
All right. But like I was saying to Glenn and Tamara, why do you think that would create separate classifications and not a smooth continuum?
I don't know.
Okay.
It's a tricky
Ethan?
question. Maybe like, I don't know, like in Tenafly, maybe like the people who are making around like $1.4 million for the cluster, like they have like one kind of job, like they're all like working something.
Okay.
And one job in like New York City or something like
Okay.
Wall Street, and like around 600,000, they're like in a more low income job, kind of like I don't know.
Okay.
An example would be a job that's 600,000 that like a lot of people can do around.
Okay. Yeah, I think that's another valid hypothesis. Maybe the people who live in these homes are people who work in Manhattan, whereas people in these homes are people who work in, the west side of the Hudson. I don't know. These are conjectures, but I want you to think about possibilities, because that's what we do with statistics. We look at a graph, we look at statistics, then we do detective work based on what we see. Hill versus non-hill. Yes?
This is a little off topic, so you don't have to answer it. But how do you think this graph would compare to like another like average town? Because you know how Tenafly is considered to be pretty wealthy.
Mm-hmm. Yes. The question is, how would this graph compare to another town? If you were to compare this graph with my town, I would expect the same shape. I would expect skew to the right and also multiple modes, because there are a few people who can afford the multi-million-dollar homes, but the bulk of the people definitely cannot. And we also have different neighborhoods or parts of town, like Tenafly. And one I know from living there my whole life is noticeably wealthier than the rest. However, the distribution would definitely be shifted to the left. I would say the median home price in my town is $200,000 less than Tenafly. In terms of the range, where I live, there's probably homes that are, up in this area. Maybe not so much. Like I wouldn't be surprised if it went up to maybe like 2.5 million. So maybe less of a range, and less variation overall, but same shape I would expect. And then I gave you the median, 820,000, and I gave you the mean, that 1.2 million. So compare those with your guesses. And I'm just running out of time, so I'm just going to say some things. These numbers are so different because we have so much skew. We have skew to the right, so I expect the mean to be higher than the median. It's because of those extraordinary home prices on the high end, and the fact that there's relatively few of them compared with homes on the low end. You'll find the same thing if you look at the median and mean Yankee salary. The mean Yankee salary is much higher than the median Yankee salary. And that would go for probably most professional sports teams. Which one do you think is more representative? This is open to debate. Usually when there's extreme skew, people go with the median, because median is not affected by that skew, and thus could be considered to be more representative. Because this mean is going to be dragged up by those homes that are, $2+ million. Okay? So that's what I'll say there.